Hello and welcome to DeFi 2.71 podcast. My name is Seraphim, and today we're going to chat with Joe Andrews from Aztec, which is a revolutionary privacy solution on Ethereum. We're going to be discussing what exactly is Aztec, the future of rollups, privacy on Ethereum, and much more. Stay tuned. This podcast is sponsored by Euler Finance. Euler is a decentralized lending platform built on Ethereum, allowing you to lend and borrow any ERC20 token that trades on Uniswap v3. So, welcome to the podcast, Joe. It's good to have you here. How are you doing?
Great, thanks. Yeah, it's good to be doing one of these live instead of over the internet in COVID times. And it's good to see the whole studio. Thanks for having me.
I hate the internet ones. I just really bloody hate them.
It's great to be here. Thanks.
Yeah, perhaps you can tell the audience about your background and how exactly did you get into crypto? Should be a good start.
Yeah, it's probably not conventional. So where do I go back to? This is actually a funny anecdote, but I went to university in London, kind of got into coding and the first wave of startup interest back in 2013, 2014. And I was like, okay, need to be in San Francisco. So I went out to San Francisco, found an internship in some startup, and they were like a car review startup, and ended up kind of doing that for a bit. And then, long story short, stayed in San Francisco and started a food tech company, completely different to crypto. But that was kind of me being in America. And whilst I was in San Francisco, I lived in this like tech kind of frat house is probably the only way to describe it. It was one of these kind of tech community houses. It was on 6th Street in San Francisco in the Tenderloin, which is not the nicest place. And Vitalik actually came by with Gavin Wood. I think it must have been on the original like Ethereum like roadshow, like pre like the ICO, yeah. And he was trying to get people to kind of download the client and send him money. And like the house was not very nice, and like it wasn't in a great part of San Francisco, and the whole team kind of looked a bit homeless. So obviously I didn't partake. But if I had, I would be very wealthy. So that's when I kind of first like heard about Ethereum, and it kind of, the people in that house kind of were interested in crypto at the time, and it kind of like piqued my interest a little bit. But I went on a slightly different path, doing like food tech. And then food tech turned out to be a terrible business model. So that company imploded in 2017, and I moved back to the UK and did Entrepreneur First, which is like a accelerator. Started out of London, a bit like the Y Combinator of Europe. And I met, at the time, 3 other co-founders, so Zach, Tom, and Arno. And we kind of set out to create a company called Credit Mint. Actually, Tom and Zach previously had met before Entrepreneur First to build this company called Credit Mint. And Tom had a background in kind of syndicated loans, and Zach was kind of had tinkered with crypto and had like the maths and the kind of engineering background. So that was kind of how I got into crypto, and I met them on this program. And I was like, okay, I want to kind of change the scenery. I've always kind of like been on the edge of crypto. It's kind of time to take the plunge. And this was kind of 2017. So we kind of all set out to start creating, at the time, what we thought was a disruption to kind of syndicated debt, like the private debt market. But we can get into that in a minute. So that's how kind of my road into crypto, which is a bit different to most, I think.
Yeah, completely different actually. Like people usually, like I used to do like standard tech or traditional finance usually.
Yeah, it's a bit different.
Starting the food tech, man.
Yeah. It's actually kind of funny. Our new head of growth, John Wu, also did food tech and then made his way into crypto. So I'm not the only one who's come through this path. It's been a good catchment, I think.
Yeah.
But yeah, so I guess we set out on this road to put, we use Ethereum as a neutral settlement layer for syndicated debt, because in the syndicated debt world, there's lots of untrusted parties who don't trust each other, and having a kind of neutral clearinghouse is lacking from the market. So we set out to kind of disrupt that industry and realized that quite quickly blockchains were public and you need privacy for that. So that's kind of how Aztec was born.
Actually, great you mentioned that, because I was about to ask, like, why do you think privacy is important in crypto specifically? So syndicated debt, or just generally, there's a reason there's dark pools in financial markets. You just don't want other people to know what your position you've got or whatever, apart from that, what else do you think is very important in terms of, why we need privacy in crypto?
Yeah, I think it's there's two main reasons, and one is a bit more simplistic and I think just worth flagging because a lot of people in crypto even know this point and just turn a blind eye, or they actually aren't aware of this. And it depends how long you've been in crypto and whether you're just a new user or you've been in for a while. But blockchains are public. Like, in order for a blockchain to work, every node has to verify the state of every transaction, and everyone needs to be able to see everything. So it's this great innovation, but all of the data passing through it is public, and that's how you get this great benefit of distributed consensus. You can remove a middleman by effectively exposing data to everyone. And that's not how most of the financial ecosystem works. So in the Web2 world, our privacy is not great as it is, but we have far better privacy than on most blockchains today because I can't see your bank account. You can't see my bank account. And that's a status quo that most people depend on for personal security or for business, I guess. So I guess that's the main first point, is that blockchains need to get to a point where the privacy is as good as the Web2 alternatives to truly be competitive. Otherwise, you're basically giving up a large amount of personal data beyond what the Facebook, Amazons, and Googles already have on you, in order to be in control of your own assets and remove middlemen. Mm. So, me personally, I think that privacy is the last missing link to disrupt some of these Web2 financial ecosystems, and that's one reason. And then I think, given the way that blockchains work, it's a decentralizing force, so we don't have to stop there. So, the goal is to equal the privacy you get in Web2, but because now users are custodians of their own funds, it also means they're custodians of their own data. So it's up to users to actually control who sees what. And privacy on a blockchain can enable that. We're not there yet, but those are the things I think are important about adding privacy to public blockchains.
Mm. So there are quite a few privacy solutions in crypto already, like Monero, Zcash, on a smart contract basis, Secret Network, there's Tornado Cash. What do you think? They all have done great things, obviously. Yep. They've furthered the the cause. What issues do you think they have not addressed yet? What is lacking?
Yeah, it's a good question. So, they're all a bit different. So if we start at the older Moneros and Zcashes, I think the reason that they've had reasonable success, but the reason they don't have major adoption is for two reasons, I think, or mainstream adoption, I should say. One is they're built purely for privacy, and privacy is not the product. Privacy is something you need when you have financial activity. So if we're just paying each other here, no one else is in the room, we don't really need privacy. Unless we're trying to hide stuff from each other. But if there's 100 other people in the room, we may want privacy so people don't snoop on our transactions, or if we're a business, they don't see the rates that I'm getting compared to someone else. So I think the first part is purely around there isn't financial activity happening on those blockchains. So the need for privacy is one that's born out of maybe an academic need or a pure personal need, but it's siloed from the rest of the financial ecosystem. And I think the reason for that is because there's no programmability on those two specific chains. So on Zcash and Monero, it's payments. There's no smart contract language as of yet. I think Zcash are working on it, but the lack of programmability means that there isn't this hub of innovation that we both know as DeFi, that mandates privacy, because it's now created a interconnected web of individuals transacting and creating a financial ecosystem. And that's where privacy becomes important. And then you kind of look at Ethereum and some of the other projects you mentioned, and I think they've made like incredible strides to trying to solve the privacy. And Tornado Cash is one of the kind of earliest examples of this. It's had great success on adding privacy on layer 1 Ethereum. With Tornado Cash, I think even though they've had great success, it's not privacy by default. So it's a choice for certain users, which means that kind of the rest of the ecosystem is still without privacy. And that actually leaks a lot of data, because if I transact with someone who doesn't have privacy, you can start to build up patterns and use advanced machine learning techniques to kind of back out the transaction graph of Tornado Cash. So I personally believe that privacy needs to be kind of not opt-in, but by default. And the reason that hasn't really taken off with something like Tornado Cash is because there are UX considerations. It's really expensive in terms of gas, and there's certain kind of settlement or time delays you need to apply to actually get the privacy on layer 1. And for me, I think that is like not a user experience that mainstream wallets can adopt yet. So they haven't. And that's why it's always on the fringe and not built into MetaMask or Rainbow, for example.
Right. I suppose that's what you see Tornado Cash. Wow, it's fantastic, obviously, and pioneers the idea of privacy. It's like you see Tornado Cash mostly involved in some Oracle manipulations and a bunch of things that normal users will not use, I suppose, because it's just too expensive, as you say. But before we get into kind of privacy, we already started doing it, but let's talk a bit about Aztec. What exactly do you guys do? What was the journey like? Just tell us about what you guys have been up to.
Yeah, so I think I mentioned a little bit earlier, but so Aztec started from Entrepreneur First, and the company's original plan was to put syndicated debt on Ethereum, and we were kind of using Ethereum as a disruption tool for these kind of mid-market debt funds who currently had to originate debt at large banks at the trading desks, and the debt could only trade at that bank's trading desk, and it was kind of it was an inefficient market with a lot of information asymmetry. And so we set out on this journey and quite quickly realized that debt funds wouldn't go near public Ethereum if all of their kind of holdings, trades were just broadcast on a public ledger. So we realized we needed privacy, and Zach, our CTO at the time, but CEO now, set out to kind of, invent what became the Aztec protocol, or the first version of it. And Zach's got a background in particle physics and a PhD in it. So he understood the maths really well that kind of is behind a lot of these privacy techniques, and in particular, elliptic curve cryptography and ZK snarks. And he was able to kind of put together the first version of Aztec, which we no longer use, but that was kind of the point at which we realized credit mint was not the big prize here. Like, we were an infrastructure company. We needed to pivot to kind of provide privacy infrastructure for other people to kind of realize the vision of kind of credit mint down the road. So that's kind of how Aztec came about. Fast forward a few years, and we realized that the original version of our privacy protocol was way too expensive. It was kind of opt-in, as I said, a bit like Tornado Cash. And it also provided confidentiality, not anonymity, which is actually a much stronger form of privacy in a blockchain case anyway. So we set out to kind of re-architect it. And Zach met Ariel Gabizon, who is a former cryptographer from Zcash, actually, and they invented a new form of ZK snark called Plonk, which is a funny name, but it's become pretty much widespread in the industry, used by kind of a lot of the major teams, and partly because it's just, I think, the fastest ZK snark that exists, or universal ZK snark, I should say. And we can get into that in a minute. But at Aztec, we build privacy infrastructure with the view of kind of making cheap private transactions mainstream and something that a developer can easily add into their dApp with kind of zero friction cost for the end user.
Mm-hmm. Let's get into the underlying technology. You mentioned Plonk. Could you explain Plonk to as if I'm a 4-year-old? You know?
That's a tough question.
We get 5-year-olds. Let's make it easier.
Okay, so I usually think about it as what is the purpose of Plonk? So if we back up a second and we kind of imagine the world where we have public transactions going across a blockchain, and we have blockchain nodes that are producing blocks and they're validating the transactions. They can perform kind of simple maths that like 4-year-old or 5-year-old can understand, like checking balance before a transaction and after a transaction and ensuring that there's no double spends and kind of the rules of the blockchain have been followed. If you start to kind of encrypt data and add privacy, you can no longer do that because if I just encrypt some data and put it in a transaction, you can no longer test anything about that data. So this is where kind of the quite unique at the time, it's becoming very much more popular now, but a quite unique branch of cryptography came about or came into widespread attention, which is ZK snarks. So what ZK snarks enable you to do is have a proof of the computation and have that be validated by a third party, and also hide information. So you can kind of, in this proof, effectively prove that you've validated the correct running of a program, but without actually revealing all the information that you need for a third party to do that.
Mm-hmm.
So there's a lot of analogies about kind of people going through caves, or my favorite one is the Where's Wally analogy. We have a nice kind of black tablecloth here, or tabletop, but imagine there was like a Where's Wally board underneath, and I cut out a shape of Wally kind of in this black tablecloth, and the Where's Wally board was underneath. If I wanted to prove to you where Wally, I knew where Wally was without showing you where he was, I could kind of move this kind of black cloth around, and if you couldn't see the edges, you kind of know that I knew where he was, but you still wouldn't be able to find him yourself.
Right.
Which is kind of like a simple, I guess, ZK snark analogy. And what these enable is you to kind of effectively run programs, or create a program, then create a proof that the program has been run correctly. So that program can be a transaction. Basically subtract from my balance, add to your balance, destroy my notes, give to your notes. And you create a proof that that's been run correctly. And instead of submitting the transaction with all the public data on the blockchain, you send the proof to the blockchain. And the proof hides this information and gives you a form of privacy. And to go back to the original question, what Plonk is and why Plonk was invented, ZK snarks are very, very computationally intensive. So I think there's a stat that I think a computation is about 1 billion times more complex in a ZK snark. So it's very, very computationally intensive to kind of run. Like if you compare running a computation to proving running that you've run a computation correctly, it's like several orders of magnitude slowdown in performance. And they also had this other property where the historical ZK snarks, they needed a trusted setup to be run per program effectively. And a trusted setup, you may be familiar with the Zcash kind of setup ceremony, it's basically a large group of people generates a string of random numbers. And the goal of this is to kind of create a common reference string. And if only one person kind of acts honestly and destroys this toxic piece of information, you can trust the setup ceremony, and no one will be able to kind of unencrypt the proofs for the program. So before Plonk, every tiny modification to a program would require a new trusted setup ceremony. And when kind of Zach and Ariel met at a conference, there'd been some previous papers, one called Sonic, that kind of proposed a universal ZK snark. And universal basically means you could do a setup ceremony once, and then kind of reuse those points as inputs for all future programs you could write with that circuit. So Plonk was kind of some iterations on some of those papers, and it presented some massive speed ups in prover time, and also kept that universal nature. So you didn't need to regenerate these setup parameters for every single program that you wanted to write. So that was invented, I think, in 2019, 2020. Basically, for the first time, enabled you to kind of write these quite complex programs that could be actual kind of user transactions and submit them to a blockchain for validation. And the most important part, I guess, is that Plonk was fast enough that you could construct the proofs for these programs on a client device, so like a mobile phone or in a web browser. Because in order to give end-to-end encryption, you can't trust third-party middlemen. This has to happen local to a user's device.
So let's dissect this a bit. First of all, you said that computational power required for ZK snarks is huge, right?
Yeah.
But to prove a transaction is true, you don't need a billion. That's the whole idea. You don't need so much capacity to do so, right?
Yeah.
So you also said, I assume I'm a 5-year-old, so you also said it's important that everybody is able to kind of validate things. So otherwise, if you rely on a third party, it becomes sort of centralized and not private, right? Is the idea then that the validation is done by anyone, whereas the actual kind of block creation equivalent on Aztec, done by some more powerful centralized counterparties that are able to do those computations, right? Am I getting this right?
I think a better way to think about it is like, so when we put this into like an actual like L2 transaction network, there's a few more kind of steps. But I guess the fundamental like Plonk building block enabled you to kind of take usually an Ethereum transaction is a signature over some data that you send to a node, and the node checks the signature and kind of decrements or increments the balance. With a kind of network that's trying to be privacy preserving, you can no longer send a signature and public data. You need to actually fully run a transaction in the browser that says, I have 10 units. I want to give you 2. So I'm going to subtract 2 from my balance, and I'm going to add 2 to your balance. Here's a signature that proves I own 10. You write that all in a program. And then instead of sending that out for kind of someone else to validate, you create a proof that you've done that correctly. So you now send that proof to this is kind of, if you just have that stage, it's kind of what Tornado Cash does. So they take that proof and they validate it on Ethereum in simple words. It's incredibly expensive to validate it, like nearly $1 million gas. Yes, that's kind of like a single unit of transaction, but you need that to happen on the client side to give you the privacy. What Aztec then does is it kind of takes Plonk and the speed of Plonk to go a step further, and it says, okay, well, instead of sending that individual transaction to an Ethereum miner, I'm going to send it to an Aztec node. And this is maybe what you were touching on with like, it says some centralization here. But Aztec nodes, completely trustless, but they take user transactions. They can't see what's happening in a user transaction. They can just see, is it a valid transaction or is it not? If it's valid, they can aggregate or roll it up. This is where the word rollup kind of comes from. Roll it up with a group of other transactions. And then they create like a meta transaction that's proving the correctness of, say, 100 transactions rather than one transaction. So they then use like a much more complicated ZK Snark program to say, okay, I've checked that all these 100 Aztec transactions are correct. And you use a technique called recursion to do that. And you send that giant proof up to Ethereum for validation. And if that one proof is now valid, validates the correctness of all 100 individual and Aztec transactions that were inside that. So that's kind of created by an Aztec node.
Okay, I start to see it. All right. But what about the Aztec node itself? How powerful does it have to be then to do all that stuff?
It's a good question. So you can run our rollup server on like a consumer grade hardware, so like normal MacBooks. It's just a bit slow. The one we run in production, it's about a 32 core AWS machine. The reason we use that is just because we've been kind of growing the team quite fast, and we haven't spent a lot of time parallelizing the prover. Like a better design would be, instead of rolling up kind of, so our current system takes groups of 28 transactions, creates a proof for those, and does that 4 times. So it's kind of quite computation intensive. The circuits are quite big. Like the longer term decentralized model is a 2x2 structure. So you validate 2 transactions are valid in a proof, and then a bit like a Merkle tree, you kind of have lots of 2x2 proofs that are validated, and those 2x2 proofs can be run on kind of consumer grade hardware, and hopefully eventually phones once the proving system is fast enough. But at the moment, it is run on a kind of fairly beefy, but like not custom AWS machine.
So Plonk, essentially what it is able to achieve, even though these transactions are very difficult to kind of compute and put together, it's still better than the current kind of standard ZK snarks. Is that?
Yeah, like orders of magnitude better.
Right.
Like in terms of speed, like you wouldn't be able to do some of this recursion with kind of standard R1CS snarks efficiently.
Okay, I see. And the validation itself, just so I understand, get this right, that happens though on Ethereum then of these proofs.
The ultimate validation, like effectively, what you're doing is you're delaying validation. So I create a proof as a user that I could validate on Ethereum, but instead I give it to a rollup node, and instead of them validating it as one proof on Ethereum, they validate it in a program, create a proof that they've validated it in the program, send that up to Ethereum. So you have levels of validation, and as long as it's been validated in a proof somewhere, if the top level proof on Ethereum is valid, then it means that everything inside it is valid. So yeah.
Like, just wondering, just as a mental exercise, under which circumstances could a Aztec node want to submit wrong transactions or incorrect transactions? Like, what's the economic incentive preventing them from wanting to do that?
So this is kind of I guess validated by cryptography. So you can never submit an incorrect transaction. You can only submit valid transactions. So the only thing a node can do is censor transactions and not provide liveness. So it can basically look at a transaction pool and say, I can't see what's happening in these transactions, but I'm just going to take out these 5 and not put them in a block. So when there's kind of a fairly centralized system, there's kind of a liveness risk, but there's never a kind of double spend or kind of the node misbehaving risk because it's all validated by cryptography.
Because you can easily prove that that's false just by...
It just wouldn't validate when it got to Ethereum because Ethereum's like running a validation engine. It would kind of... There's only one answer and it's the correct answer, and otherwise it fails. So it would fail at the Ethereum level, and that block would be invalid, and the system would basically just still be at the previous state.
Actually, let's talk first about the features of Aztec, like ZK money, I think. Could you tell us more about what exactly that is?
Yeah, so the current Aztec network has been live since March, and it's done about maybe $55-60 million of kind of payments, despite having a pretty small cap for a large part of that. And what the network enables is private sends between like parties on the network, and then kind of anonymous withdrawals back to layer 1. And all of that's available for our SDK. And we've built ZK Money as a way to kind of showcase the functionalities of the SDK. At the moment, it's the main kind of source of transactions. It's got a large number of users. And that's kind of like the purpose of ZK Money, to kind of show developers what's possible, show them that the user experience is now kind of much more like a Venmo style experience than like a traditional blockchain wallet from a couple of years ago. what we've been working on for the last year is an improvement to the network we're calling Aztec Connect. And that lets you kind of take assets on the L2 and send them to any layer 1 smart contract. So you can interact with DeFi, basically. So we call that Aztec Connect. And there's a bridge interface that we're kind of working with lots of kind of leading protocols and developers in their community to kind of build these bridges to Aztec. And at a high level, we kind of model DeFi as a asynchronous token swap with 2 tokens in and 2 tokens out. So if you take a Uniswap example, because it's probably the simplest one to imagine, if I've got ETH on Aztec, we call that ZK ETH or shielded ETH. I can take my ZK ETH, send it to the Uniswap bridge, and get ZK DAI back in return. And all of that kind of, from an on-chain perspective, it just looks like the Aztec rollup has interacted with Uniswap. Mm-hmm. So you have no idea which users on Aztec have done that. And we can actually go a step further and say, if there are other users doing the transaction at the same time, we'll batch them together, and everyone splits the L1 gas fee for Uniswap. So you end up getting about a 10 to 30 times kind of gas savings and privacy for free, basically.
Right. So what exactly is private and what exactly is public in Aztec? Like, I think the username is something that is kind of public. Is that it, or there's other things?
Yeah, so you can see what's public and private. That's a good question. So Aztec kind of manifests itself as a contract on layer 1 Ethereum, the Aztec rollup contract. You can see every address that's interacted with that, every address that's deposited to that. And that's kind of the source of capital inside Aztec at the moment. And we kind of call that our privacy set. That's everyone who could have put capital into the system. Once the capital is inside the system, it's owned by, similar to Ethereum, a public-private key pair. But we actually have an alias system, which is kind of a shortcut to look up someone's public-private key. We need this because for encrypted transactions, it's not just enough to know where to send the funds. You need to know how to encrypt the funds. Because if I have a private balance myself, but I send you funds and I make them public, everyone can see them. So the alias is basically a way for people to type Joe and find out how I want my funds encrypted so I can receive them. So the alias is effectively public, but you can't glean any kind of identifying information from it other than the name, and that's someone you already know.
Right.
So you can't see their balance, you can't see their transactions, you can't even see when they're transacting.
When you say that people need to know how to encrypt that data, so there's different options, I assume, like for encryption of data within Aztec?
At the moment, there's not, but there is something we're working on, kind of different kind of encryption algorithms. But at the moment, it's kind of one encryption algorithm. But we need to know your public key. We need to know kind of, we don't want to pass around large hexadecimal strings. Like people pay each other by name or by kind of more human readable forms. And we just built that into the system because, I think the Aztec public keys are slightly different to Ethereum ones, and to avoid confusion.
It's actually quite brilliant. I mean, we'll get into NFTs later, but a big problem is with some NFT holders is that, let's say you go to an event and you're supposed to show your NFT. What if you don't want to show your entire collection or something? I don't know, or people to dox you to find out what else is in your wallet, right?
Yep.
Like this is a solution to sort of show what you've got because you want out of your own volition without revealing everything else in the wallet, I suppose.
Yeah, it's a way to kind of say, I have this account. You can pay me here, and I guess you're just in control of what's hidden inside that wallet, as opposed to the current status quo, which is if I look up your Ethereum address or your .eth domain, I can see everything you've done on DeFi and everything you're going to do, which is kind of something that people...
Wait, repeat that, was that?
So people always think if I... the privacy breach on Ethereum, when someone pays another person, it's not just everything you've done, it's everything you're going to do. Because I've got your address now, and I can see every future transaction that's going to come out of that wallet, which is I always find interesting.
Mm-hmm. True, yeah. let's have an example. So let's say I deposit money into Aztec, and then I want to lend that money to Euler. I
Mhm.
want to borrow. Let's say I lend USDC. I borrow, I don't know, some XYZ token. I put that into a staking contract. Do a bunch of things. How does that work under the bonnet? From like, can you interact with all these different smart contracts at the same time? Yeah, how does it get from A to Z? Basically, is just what I'm trying to understand.
Yeah, so that's quite a complicated flow, I guess. So, I mean, there's two ways to do that. So, you can either write a bridge contract that does all of that in one go. So, you can kind of have a bridge contract, we call them recipes or zaps, where you kind of go from USDC to the staked like end kind of token, and it would do all those steps in the bridge contract. Um, there's some benefits to doing that. You kind of get to amortize a very large amount of L1 gas with users, but there's also a coordination issue because you have to find users who want to do the same thing. Um, the kind of way we're going about things at the moment is a much more kind of composable way where you would write a bridge contract for each part. So let's say step one, lend on Euler and get back I guess it's e-tokens
Yep.
on Aztec. Then you can take those e-tokens and use them as collateral for borrowing. Step two, and kind of you break it out. But each of those would need a bridge contract written with that functionality, and then people would be able to interact with it through ZK Money initially, and then through the SDK.
Mm-hmm. Cool. Now, I suppose eventually it could be one transaction in the end, right? Where you do, because like, yeah, it's not because we're sponsored by Euler, but like we have a batch transaction feature, which is pretty neat. Like you can lend, borrow, liquidate people all in one transaction instead of doing one by one. I guess that helps helps to interact with Euler per se, but could that be something you could do as well on the Aztec side, where you are in Aztec, you do 5 things, and send that to L1 as one thing, and then
Yeah, so if you already have that contract written that kind of does batch transactions, it'll be very easy to kind of add like a bridge interface to it, and then you get that functionality on Aztec.
Yeah.
It's just solidity at the end of the day. So like all of the kind of zero knowledge cryptography has been hidden inside Aztec, and by the time we're kind of on L1, we're just it's as if the rollup contract is calling your kind of batch contract on behalf of some users on Aztec. So if that already exists, it would be quite simple. The batch kind of size would just be dependent on the amount of users who want to do that in a given time window.
Okay. In terms of risks, I'm just wondering what happens. Let's say, I bring my money from Aztec to L1, and let's say Ethereum shuts down for some reason. What happens then? And another example, Aztec shuts down for whatever for a few hours. What happens to your funds then?
So the case of Ethereum shutting down, I don't think it's ever happened. So I think we can we can discount that one. So I mean, we pick Ethereum because it's kind of pretty battle tested. So kind of the state of the world from like an Ethereum perspective is your funds are either inside Aztec in the Aztec rollup contract, or in some cases they may be in a bridge contract because it's a lending or a borrowing bridge that needs to kind of have collateral. So that's just the same as kind of the first part of the question, I guess, is just the same as like what happens if you have funds in Euler on L1 and Ethereum shuts down? Like the funds are just still there until it comes back up again, or if you have them in a wallet. If Aztec disappears, at the moment we are the only rollup node, but with the launch of Aztec Connect, we're kind of open sourcing the rollup provider software, and we have this what we call an escape window on layer 1. So we're kind of the authorized rollup provider for 8 out of every 10 hours, and there's 2 hours out of every 10 where anyone can submit rollup proofs. So if we disappear, someone can take the open source code, same code that we run, spin up a machine and kind of keep the network running. And over the year, we're working on kind of different decentralization kind of initiatives to test out how to kind of add more nodes in and kind of remove that centralization risk.
So you're not going to probably keep that 80% when you mix. It's just you're trying things out now to see
Yeah,
how
at the
it
moment it's
scales.
kind of like it's a little more efficient while we're upgrading stuff to kind of just be the sole provider. But we're kind of making, I guess, giant leaps towards decentralization. And I guess the minimum thing we felt users needed was an option to kind of get out of the system should we leave, and that's kind of what the 2 hours is
Yeah.
for.
So even if like you get shut down, there's 20% of nodes that have that information. They can
The
turn back
information's
on.
all on L1, so like anyone can kind of take this code, spin up the node, it will sync, and it will kind of then start accepting transactions. And users could use that to withdraw, or they can keep running the network using that. It's not the ideal situation for kind of the long term, but kind of the long term state is like fully decentralized. Anyone runs a node. There's kind of thousands of nodes like on Ethereum.
So in terms of bridging contracts between Aztec and Layer 1 dApps, how would that work? Does someone have to create it, or like is that service in and of itself run by Aztec nodes, or how decentralized is it?
Yeah, it's a good question. So we have written a few bridge contracts ourselves, but kind of we started like thinking we would have to write quite a few of them. Quite quickly through our grants program, we've had about 40 different applicants for most of the kind of major protocols apply. And it's a very kind of like decentralized community first approach to writing these bridge contracts. They're quite simple to write. Simplest ones are kind of like 10 lines of Solidity code. It really depends kind of what the bridge is doing. I think some of the most complicated ones we've seen so far are about 500 lines of code, but they're still quite small contracts. And the process is kind of applied to us for a grant. We will kind of make some kind of the team available to kind of help you write the bridge, give you some kind of pointers, and then any kind of bridges that kind of seem like they're well tested and something the community wants, we'll put through an audit. We have lined up kind of in February. You don't need to go through that process. It is permissionless. You can just deploy your bridge and register it on the rollup contract. But in the short term, we're only going to kind of put audited bridges that we've kind of been through a little bit of a review of in ZK Money. But if you want to kind of run your bridge with the SDK, you can kind of do that. There's no kind of whitelist. It's completely permissionless.
So the bridging contract lives on Aztec. Right?
No, it lives on L1.
Okay.
So it's just an L1 contract, normal Solidity contract that interfaces with our rollup contract.
Cool.
The execution environment is L1, and it's kind of a reason why I think it's been quite easy to get integrations here, because a lot of protocols have a lot of moving pieces. So let's say Element as a protocol, they need Balancer, they need a few different protocols in place for their protocol to work. And most L2s don't have an ecosystem in place of contracts deployed to L2. And with the Aztec Connect model, the execution stays on L1, the liquidity stays on L1. It's just like the rollup contract itself has interacted with your protocol.
Right.
So the bridge is just kind of a translation layer that says on Uniswap, it's called a swap tokens. On Euler, it's called deposit or something. But they're all effectively, you're taking some form of tokens and getting back another form of tokens. Right. So the bridge interface is just a way of kind of standardizing that, so the rollup can understand what tokens it's received and what tokens it's sent. And then the actual kind of tokens are then dispersed back on Aztec to the users who took part in the transaction. So the only thing happening on Aztec is kind of the dispersion and the original kind of spend transaction.
Right. Might sound like a silly question, but you said it's permissionless in terms of deploying these bridging contracts. Like on Euler, there was a thing we discussed the other day, actually a few weeks ago, that you can create permissionlessly lending markets on anything, right? To do that, all you need to do is a smart contract of the token, right? Problem is, you kind of do that through finding the name of it on the UI. But apparently you have lots of malicious tokens that have the same names but different smart contracts, you know? So in theory, you could be interacting with a fake Ethereum. On the UI, we obviously filter that, you know, but on the smart contract level, because you can permissionlessly have tokens, like it can be something that looks like Ethereum, but is actually not. How do you said that there's some sort of a kind kind of you use your judgment to tell people what is a good bridging contract, what's not. But in theory, could you just use permissionlessly any bridging contracts? Like who's like the authority in terms of deciding down the line what contract's good, what's not? I don't know if it's a silly question or like
No,
too
I think it's a
detailed.
good question. I think so. The authority on the network level, so Aztec network, is completely permissionless, and you can interact with any bridge contract through our SDK, and that's kind of one of the things we felt quite strongly about, and that's like the model we're going for in the long term. Through ZK Money, which is kind of our product or showcase built on top of the SDK, because we're attracting users' funds there, and we're the one like originating the transaction through ZK Money in the browser, or the user's actually doing it. But because we're kind of making that bridge available, we will kind of only put like a short list of bridges there where we've checked the tokens are what they say they are, and the bridge is not malicious.
Right, so it's a UI thing.
Yeah.
But in terms of permissionlessness, it's there.
Yeah.
Like, okay. Actually, we talked about client node. That reminds me, I wanted to ask. So I think a big reason why Ethereum is decentralized as it is that there's different kind of software you could use to do what you wanted to do, unlike other blockchains where there's just one, right?
Yeah.
I suppose that decentralization factor works pretty well, right? You can have different software doing the same job. But what about Aztec in terms of decentralization of software? Is that something you guys have planned, or you think that's not necessary? What do you think?
It's a good question, actually. At the moment, there is one client implementation. I think that the beauty of a ZK Snark, though, is that it's the verifier that is kind of accepting the proof of transactions.
Right.
So as long as you have a proof, it doesn't really matter how you generate it.
Like as long as Ethereum has decentralized
yeah.
software, like that's fine.
Yeah, I mean, there is a liveness issue on Aztec, and I think it would be good to have multiple clients in the future. And that's once the network's fully permissionless, I think that would happen. The code's open source, but I think the effects of it are slightly less on Aztec because we don't have consensus. We rely on Ethereum for consensus.
That makes sense, actually. Yeah. Okay. How about gas? Like when you bridge things, when you interact on Aztec, how exactly is gas kind of spread around, or like how do you decrease it versus other rollups?
Yeah. So I think one thing that we decided early on was that we're going after a slightly different class of user to other rollups. When you have privacy, things are going to be more expensive. Like we're not going after kind of fraction of a cent transactions on day one. We think we can get there, but we're kind of more focused on like 10-cent private transactions as a good near-term goal. And the reason for that is when you encrypt data, usually the encrypted data is larger than the unencrypted data. So there's more data, and it's just slightly more expensive to process on Ethereum. In terms of gas, though, one of the great things about a rollup is the cost of verifying a rollup proof is independent of the amount of computation inside the proof. So you can have gigantic rollup proof, and it will still cost a fixed amount of gas to verify on Ethereum. It's around 500,000 gas with our kind of latest research. So if you have one transaction in that proof, it costs 500,000 gas to verify, plus any of the kind of data you need to broadcast on Ethereum. If you have 1,000 transactions in the proof, it's like 500 gas for a given kind of transaction. So the verification is not the kind of gas cost that really matters on Aztec. We've kind of amortized that to kind of pretty small levels. The thing which is actually the driving or dominant factor in gas costs is the amount of data we broadcast with the transaction. So telling you that your balance has changed, and kind of giving you access to that data and telling you where it is. So it basically comes down to around 5,000 gas for a transaction, like base cost on Aztec. So that transaction is kind of the base cost for a send to another user on Aztec to their username, or kind of a withdraw or a shield transaction. If you're doing a DeFi transaction using Aztec Connect, there is an additional gas cost, which is your share of the L1 transaction to kind of do the DeFi interaction.
Mhm.
So Uniswap, it's about 140,000 gas, 150,000 gas for the L1 interaction. The good kind of mental model I have is that you kind of get privacy for free. And at worst case, you pay 140,000 gas and get private Uniswap. Best case, there's lots of activity on Aztec. And there's 100 other people doing the transaction at the same time as you. Then you're going to pay like 1,400 gas plus 5,000 gas for the Aztec transaction. You'll pay 6,400 gas for a Uniswap transaction. So there's kind of two parts contributing to the overall gas cost that the user pays. One part is relatively fixed from the cost of privacy, and then one part's a bit more variable depending on how many people are in your batch for kind of the L1 DeFi. And we're focusing at the start on kind of use cases where it's easier to build a bit of a network effect, create larger batches. So kind of low latency, like yield lending, borrowing, where kind of you can batch transactions over an hour maybe compared to trading. And as we speed up the rollup and we get more and more usage, we'll start to kind of focus more on the trading use cases where you need kind of more users in a much more frequent time span.
So at the moment, the batch is sent over every hour or so.
With the current kind of Aztec 2, which is just payments, we backstop at about 6 hours, but the system's a bit less performant. The batches are max 112 transactions, and the rollup will either go when it's full, which is 112 transactions, or 6 hours. With Aztec Connect kind of launching in the next couple of weeks, we will be increasing the size of the rollup to around 896 transactions per rollup. And we'll be kind of moving up the kind of backstop time to kind of roughly every 2 hours. And I think that's good enough for most kind of yield use cases. But likely what happened with the current system is we kind of reach a full rollup, and rollup's kind of going on average much quicker than every 2 hours. So the goal is to get to kind of Aztec blocks going every like 1 to 5 minutes with kind of lots and lots of transactions in them.
Yeah, since you just mentioned rollups, the rollup space is quite interesting. So when you look at rollups nowadays, they seem like the place where you do everything, like Arbitrum, Optimism, all these rollup solutions. Well, that's great. I think one problem that it creates a bit is that, so for instance, we're a lending protocol, right? And our oracles come from Uniswap TWAPs on the mainnet. Now, we could take that pricing to a rollup if things are going on in the rollup. That centralizes the system a bit. You have to kind of introduce a bunch of changes to that. And also, it would be kind of ideal if we had faster transactions, but everything happens in the mainnet. Like it just would be ideal, because otherwise, not only do you have to move the TWAPs there, but also you rely on liquidity in that rollup being good. Otherwise, you have to kind of bridge in between rollups on mainnet. So if I'm a liquidator and somebody borrowed so much on Optimism versus their Ethereum on Optimism, I have to rely on the pool within Optimism to be liquid enough for me to kind of liquidate that user. Otherwise, I have to go bridge it to mainnet and do all that stuff. So rollups seem to create fragmentation of liquidity. Some solutions are let's create some sort of a protocol that kind of combines all these rollups somehow and creates one efficient pricing kind of a solution there. That's one solution. But what do you think about this space in terms of fragmentation of liquidity? Like, how does Aztec intend to build dApps on top of it, or like that's not exactly the use case? What do you think?
Yeah, so in our long-term plan, we do intend to build some dApps, but it's not the same approach as other L2s. So Aztec's focus from day one is on privacy and kind of scaling privacy. And that's the purpose of our L2, is to scale the cost of a private transaction, not just replicate Ethereum kind of in a different execution environment. There will be dApps on Aztec in the future. And we have a smart contract language that we're building called Noir. It has one major difference though, which is the language has like private primitives. So you can have private logic and private like state variables. So we imagine that the dApps or kind of applications you'll build on Aztec will be applications where you need privacy as part of kind of the lending market. There'll be some parts which are private, and there'll be some parts where the liquidity is likely on L1 still. So it's kind of a bit of both. Like the ownership could be on Aztec, and then maybe complicated fund structures that are needed to kind of define ownership and kind of certain thresholds. But the protocol itself, sometimes it's better just to have the complicated protocol logic on L1. So that's kind of Aztec's vision for like where dApps live in the future. But in terms of fragmentation of liquidity, I mean, I agree. I mean, I think for a lot of these protocols, it's not just the liquidity, it's the kind of other protocols that sit around your protocol. Like if you have a curve pool for some of the assets that your protocol kind of generates, and like there's not curve on kind of the rollup you pick yet, or curve's not liquid there, you have this like multi-dimensional kind of like network effect you need to kind of recreate on every rollup system.
Yeah.
And it's taken Ethereum many years to do that. So yeah, I think fragmentation is not good for the ecosystem. And that's why we took the deliberate decision with Aztec Connect to interact with L1 and try and be a bit more modular and kind of add functionality to Ethereum rather than kind of suck liquidity out of it. So I think that's a great point. I mean, the other issue I think with rollups, and sorry for going on the other issue with kind of some of the L2s which are taking liquidity from Ethereum and have their own execution environments. And sorry for going on a bit of a rant here, but it is there's a liveness guarantee, and especially for like lending markets. So let's say that, as you said, mainnet is your kind of price feed, and the L2 sequencer goes down. So what happens in that scenario? Like it goes down for 4 hours, and you get now some pretty major price action in those 4 hours. So ETH goes down 20%. So there's been a load of users who have Euler on the L2 trying to send transactions to the sequencer. There's a load of kind of liquidators trying to send transactions to the sequencer to liquidate transactions. And so let's say we've got 5,000 transactions waiting for the sequencer when it comes back online. It can come back online and say, which order should I execute these in? And it kind of has complete free reign over like what actually happens because unless it's coded into the kind of protocol of the L2, it can just pick which transactions go in the next block. And the price on mainnet is 20% below the price on the L2. So kind of a lot of money can be made or lost in that kind of first block that goes back onto the L2. So there's kind of this liveness guarantee that I don't think a lot of people really understand and have like modeled out, which I think is a big risk to some of the kind of protocols that rely on oracles for their kind of stability. And as I said previously, I don't think Ethereum's gone down. So it's something we all kind of rely on for decentralized finance, and adding this as like a potential option for an L2 to go down is quite scary for some of these DeFi protocols. And if you can trust that with the Aztec approach with kind of L1 liquidity and L1 execution, if Aztec goes down, Euler on L1 is fine. It just keeps going on. Like the price is still coming in from kind of the Uniswap TWAP oracle. If there's price action, the worst case scenario is that users on Aztec may get liquidated because they can't submit transactions to kind of, I guess, save their underwater position because Aztec's down. But the whole protocol hasn't gone down. Like the whole kind of L1 protocol has gone down. And we have like a backup mechanism whereby we're encouraging developers of bridge contracts to build in functionality where someone can save a kind of underwater position if Aztec does go down. But it shouldn't go down because we're being quite decentralized on how we think about rollup providers.
But conceptually, the difference between the two scenarios where liquidity is on L1 and liquidity is on the L2, but both L2s go down. So obviously, well, let's say it doesn't go down. So the benefit is obvious because your liquidity comes from more liquid L1. So that's
Yep.
good. The TWAP, the Oracle, is actually L1 Oracle. So that's better. If both of them go down, though, I don't quite see how different the effect is, though. Like, how is it different if both of them are down? Like, the users still get liquidated, don't they? Like, in the same way, they can't put transactions through. Or am I missing something?
So your protocol, so this is not from a user standpoint, but from a protocol like Euler, like the rest of, because Ethereum's not gone down,
Right.
all users who haven't decided to use Aztec, their positions are still fine. Like Euler's responded to kind of the system as is, whereas on another L2, like that whole instance of Euler has gone down. And you could argue like they're kind of the same because if there's the same users on both, like there's a kind of a lot of users are going to have lost some funds or in that liquidation scenario. But I think the point is that it's a lot easier to kind of enable the users on Aztec to kind of save their position because there is an L1 contract that they can always interact with.
Yeah.
Like the effect of Aztec going down is not as grave as a kind of L2 going down.
It definitely makes sense because Euler survives on L1. Whatever happens, worst case, you submit that transaction, offsetting transaction, or like the transaction on L1 directly. You have to lose a bit of privacy, but maybe there's a way around it. Whereas if it's on L2 only, like some of the protocols are built on L2 alone, like they're just gone for some time. Makes sense.
Yeah, and I think like in our case, like the worst case scenario at launch for Aztec is obviously you wait till the 2-hour window where you can submit a proof is, and like Aztec, you run the code yourself to save your position because it's running on L1, and so that's not ideal in the early days, and that's why we're working on kind of increasing the decentralization of the network, so those users have even less risk. But I think it's been a key kind of, I guess, driver for protocol integrations that we deal with L1 because you don't have to worry about that. It's only the users who have to worry about those risks, not the whole protocol.
Super cool, actually. Yeah. Funny question, but could you do like a rollup on a rollup? Like, could you do Aztec on Arbitrum or something like that? Like,
yeah, it's something we're considering. So Aztec can run on pretty much any, definitely any EVM compatible chain, and also any chain that has kind of Turing complete smart contracts support kind of elliptic curve cryptography. We're considering becoming an L3, I guess. It's a narrative that we may push later this year. The way we're kind of viewing it at the moment is we need, as I said earlier, financial activity to kind of really start in those kind of L2s before we think about deploying there. Polygon could be a good first candidate. It's not a roll up, but it's like it's a side chain or eventually maybe its own blockchain that kind of could benefit from the privacy benefits of Aztec and now has a pretty large amount of financial activity. So it's something we may consider later this year.
Do you know this senator? There was a hearing and the senator was asking the kind of ridiculous question to tech guys. He was like, if I had my iPhone here, then where am I? Stuff like that. So that's going to be me now. Like if I am on Aztec and I want to use the liquidity on level 1, but all the borrowing, lending, like let's say I want to put a short position on, I don't want that, like, I don't want every of that transaction to go through L1 first. I want to kind of use the liquidity, but keep everything else on Aztec. Is that something that's possible or that's like ridiculous?
No, I think that's, so just if I understand you correctly, you've got DAI on
I told
Aztec.
you I'm going to sound like that guy, you know.
Yeah, so let me try and work out if you are that guy.
So is Google in my iPhone?
What is DAI? So if you've got DAI on Aztec already, and you want to kind of use your DAI to open up a short position on ETH.
I think I have it. So let's say I have DAI, as you said, on Aztec, And instead of taking that DAI, creating like Aztec DAI, putting on, or ZK DAI, putting onto Euler and lending and then borrowing and taking like Ethereum back to that, I could just straight away not convert ZK DAI into eDAI on Ethereum, but just ZK DAI, borrow against ZK DAI straight away, ZK Ethereum. But I use the liquidity from Euler on L1. Is that?
Yeah. So
is that my iPhone in my Google?
Kind of, yeah. So I mean, that's the effect, like what you see when you I guess type in your Google. But what's happening under the hood is your ZK DAI is just DAI owned by the Aztec rollup contract.
Mm-hmm.
So when you spend ZK DAI, you're just telling the rollup contract that you want to kind of, we call it ZK DAI because it's shielded. We don't know who owns it until you say you want to spend it. And even then, the contract has a proof that someone owns it and wants to spend it. So you take your ZK DAI and you tell the rollup contract, I've got the ZK DAI here, which is a claim on the DAI that you have. And I want you to take that and I'll send it to Euler. And I'm going to get back some ZK ETH, let's say. I'm going to get back some ETH, sorry. So let's back up. Start again, because it's getting confusing. So you start with ZK DAI, which is just a claim on the DAI that the rollup contract has. So you submit your transaction on Aztec or ZK Money, and your transaction says, okay, I want to take my ZK DAI and interact with this L1 bridge contract. So when that transaction is validated on mainnet as part of a rollup block, the rollup sees that and it's like, okay, I've got some DAI, which the user has a ZK DAI. I'm going to take my DAI, send it to the bridge contract, and I'm expecting back some ETH. So the rollup contract gets back some ETH, it records this, and then there's some work that happens kind of completely trustlessly to disperse that ETH to all the holders who basically put in ZK DAI in the original DAI transaction. So you end up with ZK ETH. The rollup contract has just sent some DAI and got some ETH back, and we call it ZK DAI and ZK ETH because you have a claim on it on Aztec.
Right, got it.
So yeah, kind of how you imagine, but under the hood, DAI and ETH are moving on L1.
Right.
And the ZK version of it is just your shielded version of it on the L2.
And final question about this particular example is the oracle, the pricing of that DAI and ETH, that's derived from L1 to confirm, right?
Yeah.
So because it's interacting on basis level with Euler on L1. So
yeah, it's just L1. Yeah.
Okay. Cool. So my Google is in my iPhone then, all right. Got it. Okay. How do you think the rollup space will evolve in 2022 and beyond? Like, what do you think is like the biggest trend, apart from everything becoming more like Aztec?
It's a good question. So I think it's going to be a pretty exciting year. There's a lot of projects that are kind of moving out of like testnet or testing phase in kind of the first couple of quarters of this year. Some of them have been live since last year, but it's going to be interesting to see kind of if they live up to expectations, if they overpromised, underpromised, and kind of where things shake out, with like functionality, composability. So I'm super excited to kind of see all the stuff that like everyone's who's working in the space is working on a really smart team, and like they're all like great people. So it's really, really exciting to kind of see those projects become live. And I'm just excited to see kind of what becomes possible. In terms of like how I see the space kind of shaking out, I think there's going to be some consolidation because of the fragmentation we talked about. And we kind of just think about it as like, if the kind of major source of transactions becomes a rollup, other than Ethereum, will be an L3. If not, we're happy kind of being an L2. If people are happy using Aztec and the bridge functionality to get these 10 to 30 times gas savings and privacy. So it just really depends on kind of what the users want at the end of the day. A lot of protocols are pushing what they think the users want, but now we're going to be in a point in time where we can just see through adoption. So I think that's going to be pretty exciting.
Cool. Somebody asked from the audience when token, when Lambo. I guess we're going to skip that one. But Yeah, thanks a lot for coming on, Joe. I think it was a really cool, like as technical as I can handle talk, pretty much. Thanks a lot for that.
Cool.
There's going to be an event. So we're both going to Denver, I assume. On the 19th of February, there's going to be a side event for friends and family of Aztec, Euler, and Notional. So if you're one of those people, please make sure to come along. How can we find out more about Aztec?
It's a good question. So we've got some developer docs. If you just search for Aztec Connect starter kit, it should come up, or you can kind of join us in our Discord. I think the link will probably be in the description at some point of this podcast, or you can ping me on Twitter. It's JAOSEF, and I'll send you any docs you need. And developers.aztec.network is probably the best place for developers to kind of get started. And yeah, we'll see you in East Denver. We'll be sponsoring the hackathon. There'll be $15,000 ZK DAI bounties for the best bridge contracts. So if you've got some ideas of kind of how to add some privacy mechanics or scaling to your favorite L1 protocols, register for the hackathon. There's a virtual attendance or in person, and come and say hi at the drinks event as well.
After this podcast, I got very. I can do it now, babe. I should register. Well, man, thanks a lot. I'll see you soon then.
Thanks a lot. Yeah, and thanks for having me.
Cheers.